Welcome back to 14 Minesweeper Variants again. Not finally, but I'm finally done with segment 8, and segment 8 was really something. Okay, how to do product. Yeah, this is one of the more special variants in the entire initial 14. Yeah, one of the more special variants. Although there are some other variants that are a lot more complicated in this one. Product might seem complicated at first, but we'll figure it out along the way, shall we? Alright, product. Clues represent the product of distances to the nearest two mines. Okay, so what does that mean? Using Pythagorean theorem here, this is why we get square roots. We can calculate the distance between the center of the cell and the center of the cell containing the clue and the center of the cell containing the mine. If we take this distance to be exactly 1, that's just number we're taking here, we can calculate everything else in relation to that. And so let's just take a look at a couple examples here, shall we? Okay, orange is a fine color. So let's say this is our clue over here. This is our clue. So this is a distance of 1. We've assumed this constant to be a distance of 1. This will be a distance of square root of 2, because if you take a look at the Pythagorean theorem over here, if this is a 1 and this is 1, this would be a square root of 2. So if you had a mine here and a mine here, then the closest two mines are 1 away and square root of 2 away, which means that your clue would be the square root of 2. Yeah, that's actually just it. And yeah, that's really just it. So here you can see root 5 is root 5 times 1, root 10 is root 2 times root 5, which multiply to root 10. 2 can either be 1 times 2 or root 2 times root 2. So yeah, because root 2 times root 2 does equal to 2. So yeah, it used to be a really complicated variant for me, but now I think it's slightly better because you can do a lot of coding. For example, this can't be a mine. And the reason why is because if it were a mine, this 2 is basically guaranteed to be a root 2 times root 2. And that's because it can't be a 1 times 2. If it were, then how would it count this? This is technically closer to it than the mine that's 2 away. So if this happened, it would be guaranteed to be a root 2 times root 2. But as you can see, there's no space. There is no other mine that is you can put that is the distance of root 2 away. So this can't be a mine. And actually, the game is actually smart enough to figure it out by just coding. So clicking the clue does give you that clue on its own. Okay, 1 we know must be a 1 times 1. And the reason why is because I think I proved this a while ago. If you assume 1 to be equal to the multiple or the product of two values, then if one of them was a value, the other one have to be 1 over that value for it to cancel out to be 1. And so if both of these refer to mines that are at least 1 cell away, then they both have to be exactly equal to 1. So 1 is just 1 times 1. By somewhat similar logic, the square root of a prime number is actually always equal to 1 times that square root of a prime number. So 1 times so root 2 is 1 times root 2, root 5 is 1 times root 5. Root 3 does not exist because there is no cell that is a distance of root 3 away. Root 7 doesn't exist, but yeah, the most common ones are root 2 and root 5. Those are all exactly equal to 1 times the square root of itself. Yeah, 1 times itself, because you know, I did a proof in that video where I focused on it. I think that was like the second. Yeah, the second episode of the demo. I went pretty deep into product. Okay, so now what we can say about this 1 is that because this 1 must be a 1 times 1, then there are at least 2 mines next to it in these 2 cells here. And either way, you always have to have at least 1 mine there, right? The reason for that is because it's just min-maxing. Yeah, if there's 2 mines in here, then there'll have to be at least 1 mine there. And that actually does fulfill the 2. The 2 is a 1 times 2. So you can't have 2 1s because it will just calculate those 2 1s as part of its products, which fail. And so if you already have 1 mine here, you cannot have another mine here. So that must not be a mine. In addition, there can only be 1 mine in here, so the other mine for the 1 has to be here. There you go. 2... Okay, 2... this 2 and this 2 now work together. This 2 again has 2 options. It can either be 1 times 2 or root 2 times root 2. However, root 2 times root 2 is not possible because a mine here and a mine here would just fail. Fail this 2, I mean. So it has to be 1 times 2, which means that's a mine. And because of the 2, there cannot be mines that are root 2 away. So those are non-mines. Now this 1 must have a mine there. Okay, and you can't see anything else. So yeah, how the game calculates it is you can in fact have mines that are you can have multiple mines that are the larger distance away. So you can have a 1, a 2, and another 2, and that still fulfills this 2 because the 2 nearest mines are this one and one of these. Whichever it is would give you a value of that. Alright, now this 2 is either a 1 times 2, and you'll notice, oh, it can't be 1 times 2. You already see something that's root 2 away. So it must just be root 2 times root 2. So that's not a mine, and one of these are mines. This 2 is a root 2 times root 2, as you can see. So that's not a mine, therefore that is. This is a root 2, so it's just a 1 times root 2. So that's not a mine, and one of these are. Now, because one of these are mines, this root 2 can't see another thing that's 1 away. 2 root 2 already sees one that's root 2 away. So I think it must be 2 times root 2. Yeah. It can't be 1 times root 8, which is what 2 root 2 is actually, because there's already a lot of stuff that's between them. So it must be 2 times root 2, which means these are both non-mines. One of these are mines, which account for the 2 in here. This 2 is also not 1 times root 8 because it already sees something that's 2 away, and 2 is closer to it than root 8. So these are both non-mines, so those are both mines. This must not be a 2 times root 2, so that's a mine. And tada, with 3 cells remaining, those are all mines. Yay! Okay. So yeah, that's really just how it is. Okay. Let's keep going. Aha, root 5. Well, root 5 is just a 1 times root 5, as I've said before. Square root of a prime times 1 is just... square root of a prime is just 1 times itself. And so, if this is 1 times root 5, then you'll notice that there will be 1 mine in one of these, and then 1 mine in one of these 4 cells. So whatever's in between cannot have a mine in there. So these are all non-mines. This isn't a mine either, just realized. And I think the game is actually smart enough to call that for you. So that's funny. This one is also similar, that's not a mine for this root 5. This one, well... there's only 1 mine there, but this one could have mines here and here. I guess one way to say is this root 5 actually puts a mine in one of these cells because it must see that it's root 5 away. So this root 2 already sees here, so it can't see anything that's 1 away. So that means that both of these are non-mines. Now this 1 and this root 5 interact because there's only 3 cells here. At least one of them have to be in here, which would complete the 1 away for the root 5. So that's not a mine, therefore that is. Also that's a mine. Sweet. This 2 must be a root 2 times root 2 because you already see something that's a root 2 away. So that's a mine, these are both not. One of these are mines that will complete this root 2, so that's not a mine. Now this 1 is just it's just trivial. This 1 is just a 1 times 1. This one needs to see something that's 1 away, so that's a mine that isn't. Root 2 means that's not a mine. 4 mines remaining, so those are both mines. There you go. It's not that hard actually, if you think about it. You just gotta like... over time as you play, you'll start to have sort of a feel of what these square roots mean. Beforehand, you'd have to do the math for like root 5 being a knight's move away. And that's because this is 2 and this is 1, so square root of 4 plus 1 is 5. It's square root of 5. But over time as you play, you start to get a hold of things. There's still some pretty tough numbers to work with, like 4. 4 and 2 are actually the... Not 2. 4 is actually one of the more weird ones to work with. Because 4 has a decent number of options, and all of them seem somewhat doable. I think as you get to larger numbers, this root 2 needs to see one of the... my goodness, this root 2 needs to see something that's root 2 away. And therefore this root 2 will be complete, so that's not a mine. This root 2 needs to see something that's root 2 away, so that's a mine. This root 2... well, it needs to see something that's one of these cells? Yeah, but... again, not pretty useful. Oh, except... because one of these cells must be a mine, this root 2 must now be either well, wherever it is would count as a root 2 for this 2 over here. So it must be root 2 and root 2. So those are both empty, all empty. And one of these are mines. Now this root 2 means those are both empty, therefore those are both mines. 2 here, C is a root 2, so it must be root 2 times root 2, which means that's a mine, those aren't. Therefore that's a mine. That's a mine for that. Has to be empty then. 1 is just root 1 times 1. That's empty. 3 mines remaining, those are all mines. Sweet. Yeah, okay. Smaller boards use smaller numbers. I'm not sure if we're able to meet some of the bigger numbers when we go to larger boards, like 7s and 8s. Sometimes you get like pretty insane things. Yeah. Okay, so same setup. Root 2 times root 2 implies that that's not a mine. And yeah, I think at this point... Oh my god, wait, there's a lot of 1s. These are all just mines, right? They're all trivial 1s, yeah. Okay, this root 2, and root 2 is something we've seen again and again. We now know there's 1 mine in each of these. This 1 sees at most 1 mine there, so actually we can just use that interaction to say that there has to be a mine there and no mine there. This root 2... And this one, yeah, this one means there's at least 1 mine there. So that's a mine. I misclicked. That's my bad. Did not mean to do that. But we can just repeat. This is empty, therefore that's a mine. 2 root 2 is the larger one. Okay, well it just did this on its own for some reason. Oh, you know why? Because 2 root 2 is actually a 1 times root 8. And root 8 is actually a 2 by 2 away. So this distance to this distance is a root 8. So this 2 actually looked at this cell and this cell. Because there were no mines in there, the coding said that it can't be 1 times root 8 and therefore cancelled out all of this for me. Which is pretty interesting. So yeah, it's pretty smart in that regard. So this has to be a 2 times root 2 then. So one of these are mines. Okay. What else can we do? 1 mine here. Oh, this just has to be a mine. This one must be known as root 2 away, so that's a mine, therefore that's not. 2 root 5 is... It's either 2 times root 5 or 1 times root 10. No, sorry. It's either 2 times root 5 or root 2 times root 10, but it can't be a root 2 times root 10. So I'm thinking it's 1 times 2 root 5. Think I can call this out? Oh, it is not 1 times 2 root 5 apparently. So that's a mine, that's not. Yeah, okay, you can call a lot of this. I think at this point, yeah. Nice. That's a 4. Hey, there it is. Okay. So 1, 2, and root 2 doesn't really give me a lot of information. Except this 4. I think these are all empty. Yeah, and I cannot prove why. I mean, I can prove why, but you don't need to prove why. It comes naturally as intuition that these just can't be. Because if you think about it, if you had 1 times root 4, 1 times 4, if it was a 1 times 4, everything that is not 4 away, which means that see, like all of these are pretty like, this is 4 away. All of these are pretty weird. I don't know if they're 4 away or not, but I don't think these are. Yeah, everything that isn't 4 away basically just is not mine. I think this might be more than 4 away. See, I don't even know this distance because I never have to use it. What is this distance again? This is a 2 and a 3. That is the square root of 9 plus 4 is the square root of 13, which is actually less than 4, so this can't be a mine either. Because 4 is the square root of 16, if you didn't already know. So the square root of 13 would be less than that. Yeah, so that's less than 4, and that just breaks the 1, I guess, for some reason. Yeah, so that means this and this are not mines either. Isn't this 4 away or is this 3 away? No, this is 4 away. Yeah. Yeah. And this would not be mines either. So, yeah. So, I guess by intuition, these are just non-mines. That's really weird, but yeah. Okay. This root 2 is a 1 times root 2, so that's a mine. One of these are mines. Another 4, I think, yeah, we can do that. Oh, that's because the 4 already sees something that's 2 away, so it can really only be a 2 times 2. This 4 now can only be a 2 times 2, which means those are both mines. That's a mine for the root 2. This root 2 sees 1 in these cells. This 2 actually... not sure. Not sure. I can't call it right now, right? Yeah. Okay. This 2 could be a 1 times 2. Could be a... Root 2 times root 2. Might have to do with this one. If you see, not if you see, but if this was a root 2 times root 2, actually. Oh, yeah, it's either a 1 times 2, in which case that's a mine, or it's root times root 2, in which case that's a mine. So it's either, this 2 is either a 1 or a root 2 times root 2. Okay, that doesn't really help. I suppose if this happened though, this 2 actually does something very interesting. It just cancels out all of these cells immediately. That's also not a mine, but this doesn't break anything. However, again, the other option is if this was a mine, it will become a root 2 times root 2, in which case these are all non-mines. So the commonality here is that these are all empty. There you go. Alright, this 2 can't be a root 2 times root 2, so it's a 1 times root 2, meaning that this 2 must not be a root 2 times root 2 as a result. This 2 is now a 1 times 2 definitely. So that's a mine. That can still be mine, yes. And one of these are mines. Yeah, this root 2 has to be a has to have something root 2 away, so that's a mine. This 1 is implying there's 1 mine there, so that's empty. Root 2 means that's empty. 1 mine in here. Oh, that's a mine, yep. Root 2 again means that's empty. This root 2 means that's a mine, that's empty. Okay, this root 2 needs 1 mine, that's root 2 away. 4 or 5 remaining, and we know that only 1 of these are mines. So the rest of the cells must be mines. That's therefore empty, therefore that's a mine. Sweet. Oh, we've unlocked E. Oh, E will be fun. I already did an episode on E though. But okay. Alright, let's keep going. This 2 can't be a root times root 2, so it's a 1 times 2, so that's a mine. This 1 is implied there's 1 mine there. I can do stuff? Is it this? Wait, what? That did not give me any information. What? Is it this 2 root 5? It might be actually. But what is 2 root 5 even? It's a root 20. And that is equal to root 4 square plus 2 square. A root 16 plus 4. So how far away is that? That would be this. That would be this. Okay. And now because we already know that one of these are mines, this 2 root 5 now actually cannot be valid. So those are all empty. Root 2 implies that there is exactly 1 mine in these 3 cells. 2 root 5 actually looks pretty restricted right now as a result. And what is 2 root 5 as a result of that? It's either root 2 times root 10. We know one of these are mines as well. Oh, I guess that means it can't be a root 2 times root 10 because none of these are root 10 away. And there are 2 mines in here, so this has to be 2 root 5, I think. Which means that none of these are mines, and that is, and one of these are mines. This 2 also sees a 2 already, so those are both non-mines. Easy. Okay, those are both mines. That's empty, therefore that's a mine. That's empty. 1 means one of these are mines. That will complete this one for the root 2. 2 now can't be root 2 times root 2, so it's a 1 times 2. Oh yeah, I guess that's not mine, so that's a mine. This root 2 means that's empty, therefore that's a mine. This 2 root 2 already sees a root 2, so that must be empty. And with 6 cells remaining, those are all just mines. Nice. Okay, cool. As you can see, the one here sees a lot of mines around it. You also might begin to notice that we're ending up with a lot of just empty cells that are all just mines. It's a pretty interesting like gimmick of product, but the general reason for that is more because these clues are a lot more likely to tell you what are not mines and what are mines. The only clue that really tells you where mines are is the 1. The 1 really just says 2 mines here. But in reality, when you're comparing 1s with root 2, you always say, well, because there's 1 mine at least here, then these are both empty and this is mines. And so you end up covering you end up covering way more non-mine than mines, basically. I just cannot speak today. So yeah, that's why you get a lot of empty cells at the end that are all just mines. Okay, this root 2 means that's a mine. Definitely is both empty. 1 is just trivial. This 2 must not be root 2 times root 2. This 2 is now 1 times 2, so that's happening. One of these are mines, therefore both of these are empty. 2 can't be root 2 times root 2, so that's empty. Therefore that's a mine. That's a mine. Those are both empty. That's a mine. One of these are mines. That might affect this one. Yeah, because if it's 1 times root 8, then these would both be empty, which fail. So it's not that. Root 5 is 1 times root 5, so that's empty. So is that. 2 times 1 already sees 1 mine in here, so that's empty as well. Something that's root 5 away is that. No, one of these are root 5 away. Okay. This might send as 2 away, so that's a mine. Actually, this might help. Yeah, this is a 2 times root 2. So one of those are mines. Okay. How does that help? Well, it helps because we can now show that if this was our mine, these are both empty, which actually breaks the 1. And that's very interesting. That's not a piece of logic we've seen yet. All of the previous logics have been pretty based on math. But this one actually is based on Minesweeper logic. So this can't be a mine, these are both mines. Okay, now that's empty. 11 mines. Yeah, see, look at that. It's just all these are just mines. There you go. It's honestly just so dumb. You get a lot of empty cells, basically. Alright, let's keep going. Okay, this can't be root times root 2 because if it were, you get a mine here and here, which breaks this 2. So this must be just a 1 times 2. One of these are mines. Now this 2 must be a root times root 2 because one of these are mines, so that's not a mine. And one of these are mines. Actually, at least one. They can both be mines as well. Oh my goodness, 4 times root 2. Wait, that's pretty big. Okay, I can do that first for some reason. Okay. This again can't be a root times root 2 because one of these can't both be mines, otherwise this root 2 breaks. So it's a 1 times 2. This must have a mine here, which means they're both non-mines. These are mines. Doesn't really help. Okay. I'll have to look at this one again. Oh, I guess what? Did I put a is that because there's a mine there? I guess it might have been why. Okay, let's analyze even further about the cells that are not corded yet. The next smallest distance away that's not corded yet is 2. So how does a 4 times root 2 break? Because if there were mine here, there would be root 2. So if there were 4 times root 2, then everything below a 4 away has to be non-mine. So that would cancel out most of this. 1, 2, 3, 4. That is not a 4 away. This is actually, what is this distance? I don't even know what this distance is. That would be a square root of 4 squared plus 4 squared, which is square root of 32. That's, wait, no, it's 3 squared plus 3 squared. Okay, see, this actually does seem to work though. Because this is actually equal to 18, which is larger than 4. So this cell can actually be a mine. Actually, yeah, because it's larger than 4, it's not within this area. So this doesn't break for some reason. Okay, well, what if it saw something that's 2 away? If it saw something that's 2 away, then this must be 2 times 2 root 2. And this 2 root 2 we can just rebrand as root 8. And that will be this cell exactly. And that also works. Okay, that's really weird. So what we were saying is that this was our previous option. And then this could be a mine because that's 4 away. Oops. And then everything outside this square is always going to be greater than 4 away. Because this distance to this is the shortest distance in this like sort of squarish area. So we only have to care about what's inside. But even then, it does still look like it works. I don't get why this would fail. Like the other clues don't really interact with it much. So yeah, I guess it's fine. Yeah, and otherwise your other option would be if this were a 2 times root 8, in which case one of these are mines and this is a mine, and then everything outside doesn't matter. So that's your other option, and then this would be empty. But yeah, this cell would be possibly a mine because that is root 9 away. That's 3 away, which is a root 9, which is greater than root 8, so it doesn't really get considered by this cell over here. So what I mean to say is that we do have options. We do have options. So what else are we allowed to what else are we even allowed to look at here? Okay, I can't call it. This root 2 might be important, but this root 2 doesn't make any sense, right? If it were 1 times root 8, you just have this and this, which is very similar to this, by the way. And your other option is 2 times root 2. In which case it's this plus this. In which case one of these could still be mines. So it's this times this, basically. That's your root 2 times root 8. Oh, sorry, 2 times root 2. After which these can still be mines, so there's no difference there. So there is something I can do here, apparently. Okay, what is it I can do here? There's so many empty cells. But they're all unrevealable until I finish this because ultimate mode. Yeah, this is the kind of challenge I was expecting from ultimate mode. Because this is probably very obscure cells, right? Like, if this were a mine, that we know this this 1 times 4 root 2 just does not work out. And so what that means is that it must be root 2 times... it must be... wait. Yeah, root 2 times 4 just does not work out because it's not 4 away. This must therefore be root 2... this must therefore be 2 times 2 this kind of thing. And then all these are mines. And then that still somehow figures itself out. Yeah, I don't see the problem. Do you see the problem? Might have to consult the hint here because I'm actually just stumped as to what I'm supposed to do with this. Boom. Those cells. Those are special. What? Oh, it's this too. It needs something that's root 2 away. Can I call this? Oh my gosh, I can. That is so dumb. That is so dumb. It was a chording thing. You could chord that. Whatever. Okay, well, I can just chord the rest of this puzzle, I'm pretty sure. Yeah. Yeah, that was on me though. So it wasn't that hard. Like, it was actually not that hard. This is just a normal thing. I just didn't see it. Okay. One is trivial. This one's trivial. This one might be non-trivial. If this is 1 times root 8, then again, that will clear out all of this. This root 2 will therefore fail, so can't be 1 times root 8. Has to be root 2 times 2. This one, hold on. If this is a mine, then these are all empty. This root 2 must be there, which does not break this. No. But if this happened, then I don't know. If this happened, then it's root times root 2, which means that. If this happened, then that's empty. That's a mine. Still nothing. Okay, this one. No. This. It's a singular mine. What? Like, are you saying like if this is a mine, then it breaks, or if this is a mine, then it breaks? if this is a mine, no. If this is a mine, maybe? Not really. Doesn't really break. Okay. Oh, what? That cell? Wait, why? Oh, because it's a 2. It can't be root times root 2 because there's no space. Alright. That's fair. That one was another thing I didn't spot. Okay, so one of these are mines, we already know that, so that's empty. And then again, at least one of these are mines, so that's empty. One of these are mines, so that's empty. This one is trivial. They're all trivial from here on out because of the 1. Okay, not really. Not really. But we're getting close. One mine to be found. It's probably from here. Yeah, it's this one. Alright, there you go. This is so dumb, honestly, but sure. Okay. Let's go with 8x8. Trivial. Trivial. That's a root 10, by the way. Which sees those. I'm not going to try and explain why. They just do. That's a mine, those are not. One empty to remain. I think it might be this one, which means that can't be mine. Yep, that's the same thing I almost did not. I almost missed that. Okay, all roughly trivial from here. What about this? This 10 is either a 1 times root 10, and root 10 is actually possible through this, or it's a root 2 times root 5, which is possible like this. At least you know it's a root 2 times 2. If it were a 1 times 10, then this is a mine, and then either this is a mine or this is a mine. And because we know one of these are mines, it has to be this one, which does that to us. And if it were a root 2 times root 5, it must be like this, which does that to us. Not really sure what that would do though. Might be this. Oh, it's this, yeah. One mine over here means that these can't be mines. Alright, much better. That's a mine, those are not mines. This 10 is actually a lot easier to work with. Yeah, it... Wait, what? Oh, wait, what? Oh yeah, it's a root times root 5. I didn't see that. Okay. I still have stuff here to do apparently, so... Yeah, this has to be a mine. That makes sense. One of these are mines. We don't know which. This one must be something that's 2 away. Can we start considering if this can be 1 times root 10? Yeah, because one of these have to be... Oh wait, no, but this is root 10 away from that. Oh, this fails. Because if this happened, then we would know that everything inside... Oh, but I could still see this. Yeah. Then this would have to be a mine, right? Yeah, and then this 2 will now fail because this now can't be a mine because that will break this root 2. So this combination of these 3 clues all fail simultaneously if this happened. Should I try explaining that better? I think I should. If this is root 10 is a 1 times root 10, then this has to be a mine, followed by something that's root 10 away. That means that anything between them can't be mines, between these 2 distances. Now this 2 must be 2 times root 2, and so the only cell that's root 2 away at this point is this. Now this root 2 means that can't be a mine, and now this 2 is broken because there is nothing that's 2 away. So that can't be a mine, these are both mines. Therefore, this means that's empty, therefore that's a mine. Cool. Alright, and 12 mines remaining. Perfect. Ta-da! Okay, let's keep going. Okay, this root 2 is trivial. That's trivial. This again can't be root times root 2. So that's a mine. What? Oh, there's this one. It's this same thing. I almost missed it again. Trivial, trivial, trivial. Not that trivial. Trivial, trivial. Oh my goodness, that lag. Did you see that? Wait, was that my game or was that like something else? I don't even know. Trivial, trivial? probably trivial at some point. This one, I don't know. Yeah, one of these are mine, so this can't be mine. Okay. Trivial. This one's trivial. This one's therefore trivial. It must be a... No, it's not trivial. Oh, just kidding, it is. Why? Oh, because we recently has root 2 away. I didn't see that. This one's trivial. Therefore, two more trivial things. One of these are mines, but they can both be mines. Doesn't really make a lot of difference. Might have to work with these numbers now. Not entirely. Although I suppose if this is a mine, then you break all of these cells, which I'm not sure. No, actually we are looking for a mine, so really we should be testing if things can be empty or not. And I don't see how that would work. Right. I guess suppose this is empty, then this must be a mine for this root 2, which means that these are all empty for the 2, and now this breaks the 1, so this can't be empty, it must be a mine. Alright, sure. That's trivial, that's trivial, that's trivial, that's probably trivial, and 8 out of 14 left. Well, then I can't put a mine there, or in fact in any of these, because all of those would immediately render the remaining 7 cells unusable, and therefore, how many mines could you put left? I mean, considering that this can only have 1 mine in it, not a lot. You can really only put 6 in total. So nothing here can be mine. 1 means that's a mine. This must be root 2 times root 2. No idea how. Okay, one of these are mines exactly, which gives you everything that you need, yeah. And the way I calculated that is that because you have 7 out of 9 mines remaining, having exactly 1 mine in here would imply that there are 2 empty cells, which are the 2 empty cells that are not mines. So everything else must be a mine. Sure. Cool. Alright, let's keep going. How, oh my goodness, that just looks like a normal Minesweeper board. Okay. Yeah, I've been doing this for what, 37 minutes. That's actually a bit longer than normal. But it turns out product actually has some challenge because of the bigger numbers. Like a 4, I can click on the 4, right? No, you haven't called the 4, but I can probably just guess that these are... Oh no, those can be mines. See that? Yeah, so it turns out that 4... Yeah, you can't actually use intuition here. Anyway. Alright. So... Let's see. I think that these are non-mines. Wait, what? No, they are? If these were mines... Oh. Right. If this is a mine though... Yeah, okay. These are non-mines. And I can prove that because if they were mines, then the 2 just can't have mines here. This 2 must not be a 2 times... must be a root 2 times root 2, which means that, which now breaks this 2 over here. And by symmetry, the other side also breaks. So those can't be mines. Again, if there were mines here, I suppose this could all be root 2 times root 2. Yes. If there were a mine here, for example, then one of these are mines, which means that. Yeah, okay, I don't see anything I can do there. Wait, yeah, how is that? Okay. If it were 2 times 2, it has to be like this. And everything inside just doesn't work, but that's fine. It can be root 2 times 2 root 2. Which then implies all of these are empty. And that. So it's either this or this, right? No, clearly that's not true, because then if that were the case, I could probably break all of those cells. Although... Yeah, and the reason why is because after this, in the blue scenario, you could still have mines. Wait, what? in the blue scenario, wouldn't the 1 still all break? Because of the 2? How would the 1s be? Okay, I guess the only other option is if this 4 was... If this 4 was a 1 times 4. Right? Yeah, so okay, so 4 has 3 options if I remember right. It can either be 1 times 4, or it can be 2 times 2. Actually, let's go down the chain. It can be root 2 times 2 root 2. It can be 2 times 2. I think those are all your options. Yeah. Oh, sorry about that sniffle. Yeah, so I guess we can like go through the list. We already realized in both scenarios... Is it a 1 times 4? A 1 times 4 does still affect all these cells. Okay, so those are the 3 cells that are non-mines. So let's go through a formal like explanation of how this logic works. If it were a 2 times 2, then these are mines and these are all non-mines. This 2 now seeing a root 2 can't see anything that's 1 away. Cool. Okay. So let's mark those down. If it were a root 2 times 2 root 2, then you'd have a root 2 times a 2 root 2. Because of this root 2, again, none of these can be mines. And your final one is if it were a 1 times root 4, which I'll use red to annotate. If it were 1 times root 4, then you must have a mine that is 4 away, plus a mine that's 1 away, so everything inside just cannot be mine. However, everything on the square around it actually has free range. In fact, this cell also has free range, because this cell is actually more than 4. It's I think it's square root of 18 away, but we don't care about that cell. What we are saying is that this could be a mine. But in all cases, not in all cases, but in all 3 cases, these are all non-mines. There you go. Okay. That took a while. Alright, this could help us. Could it? If it were a... Yeah, I think this breaks the 2. If it were a... If this were a 1 time root 8, then you have 1 mine here. These are all empty. And this 2 now can't work because it already sees a root 2. It can't see another root 2 for some reason. So this can't be a 1 times root 8. It must be a root 2 times... It must be a root 2 times 2. Which also means that this 2 must not be a 1 times 2, so those are both empty. This 2 must be a... this 2 must be a root 2 times root 2, so one of those are mines, which means this must be a 1 times root 2, which means those are both empty. And now this must be a root 2 times root 2, meaning that's empty. Sweet. You can see this like sort of alternating here based on... Well, not based on, yeah, but there's alternation here. This 2 now can't be a root 2 times root 2, so that's empty. There you go. 1 is trivial. Those are non-mines. This one is probably trivial. Yeah, okay. This 4 is trivial now. It must be a 2 times 2. That's trivial. One of these are mines, but we don't know. Actually, at least one of these are mines, but we don't know which. This, yeah, I already sees 1 mine beside it, so that's not a mine. One of these are mines as well, so that's not a mine either. That's a mine. Root 10. Root 10 has to be a root 2 times root 5, right? Because there's 1 mine here and 1 mine in here. So those are both empty. In fact, because of that, yeah, both of those are empty as well. This one, I think it's just trivial. No, it's not trivial yet. Is it trivial now? Yes, it is. Yeah, just gotta keep trying. At some point, it becomes chordable. Hey, we can just do that. GG's. Yeah, this is really really a variant. It gets really funny sometimes, but it's not that hard. So yeah, that concludes power. Okay. So I'm gonna try to finish the rest of this, and then we'll get to group. Yeah. But until then, this was kind of fun, I would say. So yeah, hope you enjoyed this video as well. I'll see you guys next time. Bye bye.